हेलो एवरीवन, वेलकम बैक टू सीएस वर्ल्ड। तो आज फिर स्टार्ट करते हैं अपना AIML की सीरीज और हम चलते हैं आगे। कहाँ पे? ये रही बुक। ठीक है, तो स्टार्ट हो जाओ। कल हमारा इसके पहले तक कंप्लीट हो गया था CLT तक, सेंट्रल लिमिट थ्योरम। आज हम लोग पढ़ेंगे स्टैटिस्टिकल हाइपोथेसिस टेस्टिंग और देखते हैं। ठीक है, तो स्टैटिस्टिकल हाइपोथेसिस आज है 26/4/20। Okay, data must be interpreted in order to discover meaning. We can interpret data by using specific structural outcomes and use traceable methods to confirm or reject the assumption. The assumption is called statistics. Statistical methods to confirm or reject the assumption. The assumption is called a hypothesis, and statistical tests used for this was called the statistical hypothesis testing. Interpret data by assuming a specific purpose to confirm or reject the assumption. Hypothesis tests. Whenever you want to make claims about the distribution of data or several hypothesis tests. Whenever you want to make claims about the distribution of data or one set of results are different from another set of results. In applied machine learning, we must rely on a statistical hypothesis test. In this tutorial, result is important for quantifying answers and questions about samples of data. The interpretations of statistical hypothesis test requires correct understanding of p-values and critical values, regardless of significance. The finding of hypothesis test must be continued in tutorials. Data alone is not interesting. It is the interpretation of the data we are really interested in. In statistics, when we wish to start asking questions about the data and interpret the results, we use statistical methods that provide a confidence or likelihood about the answer. In general, this class of methods is called statistical hypothesis testing or significance test. The term hypothesis may make you think about science, where we investigate a hypothesis. This is along the right track. In statistics, a hypothesis test calculates some quantity under a given assumption. The result of the test allows us to interpret whether the assumption holds or whether the assumption has been violated. Two concrete examples that we will use a lot in machine learning are a test that assumes that data has normal distribution, a test that assumes that two samples were drawn from same underlying population distribution. Assumption of statistical process called null hypothesis. It is often called the default assumption, presumption that nothing has changed. A version of the test assumption is called the false hypothesis. A violation of test assumption is often called the first hypothesis. One or H1 for short. Hypothesis 1. फिर H1. Okay. Shorthand, some other hypothesis as well known as the evidence suggests that H0 can be rejected. Test fails to be rejected, and assumption of test does not hold and is rejected at the some level of significance. Hypothesis 0. H0. Test fails. Assumption of the test does not hold. Is rejected at some level of significance. Before we can reject or fail to reject the null hypothesis, we must interpret the result of the statistical test iteration. The result of first statistical hypothesis test must be interpreted for us to start making claims. This is point that may cause a lot of confusion for beginners and experienced practitioners alike. There are two common forms that result from a statistical hypothesis name take, and they must be interpreted in different ways. They are p-value and critical values. Interpret the p-value. We describe a finding as statistically significant by interpreting the p-value. For example, we may perform a student's t-test on two data samples and find that it is unlikely that the samples have the same mean. We reject the null hypothesis that the samples have the same mean at a chosen level of statistical insignificance or confidence. Statistical test value called p or the p-value. This is quantitative that we can use to interpret or quantify the result of the test, and either reject or fails to reject the null hypothesis. This is done by comparing p-values to the result value chosen before and cause significance level. Often followed by the Greek lowercase alpha. H0. The significant level can be inverted by subtracting it from 1 to give a confidence level of the hypothesis given observed sample data. Confidence level is equals to 1 minus significant level. So confidence level is equals to 1 minus significant level. Significance level. Reject versus failure to reject. And the p-value is probabilistic. The p-value is probabilistic. This means that when we interpret the result of a statistical test, we do not know that is true or false. Only what is likely. Rejecting the null hypothesis means that there is significant statistical evidence that the null hypothesis does not look likely. Otherwise, it means that there is no there is not sufficient statistical evidence to reject the null hypothesis. We may think about the statistical test in terms of dichotomy of rejecting and accepting the null hypothesis. The danger is that if we say that we accept the null hypothesis, the language suggests that the null is true. It is safer to reject the null hypothesis. It allows us to reason about whether or not the data fits the hypothesis, not the other way around. The p-value is a measure of how likely the data sample would be observed if the null hypothesis were true. Post hoc tuning. It does not mean that you can resample your domain or tune your data sample and rerun the statistical test until you achieve a desired result. It also does not mean that you can choose your p-value after you run the test. This is called p-hacking or hill climbing, and will mean that the result you present will be fragile and not be representative. In science, this is the at best unethical and at worst fraud. Interpret critical values. Some tests do not return p-value. Instead, they might return a test result from this data distribution that can be interpreted in the context of critical values. A critical value is a value from the distribution test. Test statistics. Statistic less than. It requires that you know the distribution of the test rather than how to sample the distribution to retrieve the critical value. This is demonstrated for standard distribution. In chapter 11, the p-value is calculated from the critical value. Again, the meaning of the result is similar in that to the significance including precision, rejection, failure, prediction, compensation. According to the null hypothesis, 5% significance levels the test found that data statistical test. The interpretation of statistical hypothesis test probabilistic. That means the evidence of the test may suggest may not be mistaken. For example, if alpha was 5%, you suggest that at most 1.20 that the mistakenly rejected because of the statistical bias. Is the data sample given us some p-value larger than our hypothesis, either meaning that the this type of logism is called a false positive. Facilitating prediction of hypothesis. Alternatively, we may not be ready to reject the hypothesis. It may mean that none needs to be got it right, and that none hypothesis is false. It won't occur to make a mistake. This type of error is called the false negative. First, you click on these two tabs. Diagram of the image shown to you. We'll start the first project. All statistical hypotheses tests have a chance of making either of those type of errors. False findings or false discoveries are possible. They are probable. Ideally, we want to choose a significance level that minimizes the likelihood of one of those errors. That is a very small significance level. Although significance levels such as 0.05 and 0.01 are common in many fields of science, harder science such as hypotheses are more aggressive. It is common to use a significance level of 3 × 10⁻⁷, often referred to 1. This means that the finding are due to chance with a probability of 1 over 3.5 million independent repeats of the experiments. To use a threshold like this may require a much larger data sample. Nevertheless, these type of errors are always present. To also reason work is about to verify the use of the necessaries. Selection of the single this systematic parameter including test result from the data sample. The degree of freedom may be determined to and which of the creating represented degree to a level of surgery statistic usage generation when no degree corrected while making the subtract now for example the sample decomposition simple symmetric. When we calculate the sample variance as an estimate of the population, see that Estimate of the population. Variance x is equals to 1 upon n minus 1 cross multiplication. This I is equals to 1 to the power n. Summation of this is minus the mean x the whole square. The correction updates the degree of freedom for the single intermediate statistic used that itself can introduce some additional uncertainty into a calculation. We will see mention and use of degree of freedom as a parameter or correction instead of a statistical hypothesis test. Now this chapter is also completed again. This section lists some ideas of extending the tutorial that you may explore. Summary. Statistical distribution. चलो चैप्टर 10 पे पहुंच गए. Statistics. And part of data distribution, and by far the most well-known distribution is the Gaussian distribution, often called the normal distribution. The distribution provides a parameterized mathematical function that can be used to calculate the probability for any individual observation from the sample space. The distribution of the characteristics grouping or the density of the observation called PDF. We can also calculate the likelihood of an observation having a value equal to or lesser than a given value. A summary of these relationships. Do you need math background for this? You need background. Yes, boss. Danish Parvez. We can also calculate the likelihood of an observation having a value equal or lesser than the given value. A summary of these relationships between observations is called the diversity function. In this tutorial, we will discover Gaussian and weighted distribution function and how to calculate the probability and probability distribution functions as such. After completion of this tutorial, we will know the integration between observation and calculation, how to calculate the probability and density. calculus, statistics, probability, algebra. Oh yeah. Thank you, bro. Okay, yeah, gentle introduction. ये तो यार पढ़ चुके थे प्रो पीडीएफ और सीडीएफ. PMF property mass function. Let's look at that. We got each in terms of their parameter providing an identity function Gaussian distribution. The end of Carl Friedrich Gauss in the focus of much of field of data from especially मीन वेरियस स्टैंडर्ड डिवीजन पढ़ी हुई चीजें हैं डायरेक्टली आगे क्या करें we can work with the Gaussian norm SciPy module. The norm property of function can be used to create a Gaussian probability density of function with a given sample space. Mean standard deviation is Gaussian period with a sample space of 5. Minus 550.001 इस जहां में है ना होगा तुमसे कोई भी संशय क्या है नौ पीढ़ी Studiative is that lot. Oh my god, bye. PLT.plot. Aditya. इस जहां में है होगा ओ भाई रन कर दिया ये आ गया गॉसियन डिस्ट्रीब्यूशन दिस इज द बेल Running the example creates a line plot showing the sample space in x-axis and the likelihood of each value of the y-axis. The line plot so the familiar bill shape कितनी बार करूँ मैं तो कर चुका हूँ भाई. Norm CDF and this is the गॉसियन CDF और ये था गॉसियन PDF। बना देते हैं, रिवीजन ही हो जाएगा। इस ज़माने में मुझसे कोई भी NumPy import arrange from matplotlib import plt as plot as plt pyplot from scipy.stats import now। अब हम करेंगे define for the distribution parameters sample stop नहीं। Hello guys, like, share and subscribe. Do not subscribe. Running the example grid plot showing S shape with the sample space on the x-axis. This is and the cumulative probability of y-axis. This we can see that the value of two curves close 100% of the observation with only very thin tail of observation distribution beyond that point. We can also see that mean value of 0 shows 50% observation before and after the point. Students T distributions. The students T ये मेरे लिए नया है यार, इसका ही निकल गया। ये क्या है भैया? Student T distribution or just T distribution for short is named of the pseudonym student by William C. Gossett. It is a distribution that series when attempting to estimate the mean of normal distribution with the different size samples. रुक जा जा। क्या है उसमें?
इडली है, सांभर है और
ठीक है, तो कहाँ पे थे? It is a discipline that arises when attempting to estimate the normal distribution with a different size samples. As such, it is helpful shortcut when you describe. Although you may not use students' distribution directly, you may estimate value from the versus parameter in order. As such, it is helpful as order when describing an or possible situations to report data from distribution. Site of sample must be taken into account. You may not use the students' distribution directly. This should describe a population quantity. For example, the mean has n degrees of freedom as null as all n observations in the samples are used to calculate the estimate of the population mean. Statistical quantity that makes use of knowledge to this. Observation in a student's t-distributions are calculated from observation in normal distribution in order to describe the interval of both. Attempting to estimate the mean of a normal distribution of A distribution are calculated in order to describe them. GoDaddy renewal mean in the normal distribution. Observations are calculated as S upon n root n. Data is equals to x minus mean x upon s upon root n. Whereas x is the observation from the Gaussian distribution, mean is the average observation, s is the standard deviation, and n is the total number of observation. n क्या है? टोटल नंबर ऑफ ऑब्जर्वेशन. Import by plot SPLT from scipy stats import करेंगे हम t को और फिर उसके बाद हम कर रहे हैं define the distribution parameters sample space range -5 0.20 POF is equals to length of the sample space -1. भाई क्या हो गया स्पेस G square distribution. The G square is denoted by the lowercase Greek nonces key. As in kite raised to second power x square, it is easier to write k squared. Like the student's t distribution, the k-square distribution is also used in statistical methods on data drawn from the Gaussian distribution to quantify the uncertainty. For example, the chi-square distribution is used to chi-square statistical test or independence. In fact, the chi-square distribution is used in the derivation of chi-square parameter of freedom of k, degree of freedom of k. Another version of chi-square is the sum of k is equals to summation of is equals to 1 to the k xi square, where the k is an observation that has a chi-square distribution. X are observation drawn from a Gaussian distribution, and k is the number of x observations, which is also number of degrees. उम्मीद ये कर थोड़ा अलग है। क्रिटिकल वैल्यू चलो इसको कल कवर करेंगे, अभी के लिए क्लास ओवर करते हैं या नहीं करते हैं, तो 1 मिनट देख लेते हैं क्या है। चलो नेक्स्ट क्लास में इसको देखेंगे। बाय एवरीवन, फिर मिलते हैं नेक्स्ट क्लास में।